Good afternoon. Today I'm going to discuss to you the module that I gave you yesterday about air density or atmospheric density. Let me show you or share to you my screen about the module that we had yesterday. So this is the competency 6 of our module. So entitled density of air or atmospheric density. Okay, so the objectives for this module are as follows. Discuss the density of air or atmospheric density. Explain the relationships of gas density and pressure. Discuss the application of gas density and calculate gas density using atmospheric density equation. Okay, so I'm not going to tackle everything about this module because I presume that you have already read and understood some of the concepts here. Okay, I'm just going to give emphasis to the air density formula or atmospheric gas equation. So the formula for air density is air density equals P divided by RT, where P is the density of air, the unit is kilogram per cubic meter, and the P is air pressure, the unit is Pascal, and R, take note of this one, is the specific gas constant for dry air, which has a value 287.5 joule per kilogram Kelvin. The temperature is Kelvin. Temperature Kelvin. Okay, so you have to take note of the units for each of these elements in the formula. So most of the time in a word problem, ang ibinibigay ay degree Celsius. So to convert that to Kelvin, just simply add 273 to the value of degree Celsius. Okay, like for example here in SAQ1, SQA1, we are going to convert the value of Kelvin of degree Celsius to Kelvin and vice versa. The given is 100 degrees Celsius. To convert that to Kelvin, just add 273 and you will be able to get 373 Kelvin. So that's how to convert degree Celsius to Kelvin. Very easy. Okay, so let's have this sample calculation of the air density. So calculate the density of gas at 25 degrees Celsius under the pressure of 600,000 Pascal absolute. So the first thing that you have to do is to convert the units, especially if it's not according to the units that we've seen here in the formula. So first, convert the value of the temperature to Kelvin by adding 273. So we got 298 Kelvin. So we're ready to go. The formula for density is pressure divided by RT. So let's substitute. The value of our pressure is 600,000 Pascal. And our R, itong R natin dito sa this is constant, specific gas constant of dry air. 27.05 joule per kilogram Kelvin. So times the temperature, so we've already convert the degree Celsius to Kelvin, 298 Kelvin. And let's do the math for this equation. So we will arrive to this answer. So more or less, kasi may, ano dyan, kanina may 8 ako dito sa 0.58. So, ganyan. But the price is still the same. So here, the conservation of unit, Pascal, 1 Pascal is also equivalent to joule per cubic meter. So, I put it there to show you the calculation of units. Cancelled out the joule, and what we got is kilogram per cubic meter. Okay, J stands for joule. So just follow this formula and you'll be able to get the correct answer. Okay? Alright. So remember class that not all the time ang R ito yung ginagamit natin. So because each gas like nitrogen, fluorine, oxygen, may kanya-kanyang value ang kanilang R or gas constant. So kapag given yung gas constant sa problem, ang gagamitin natin yung given na R o gas constant. Pag hindi given yung gas constant sa problem, gagamitin natin ang value na 287.05 joule per kilogram Kelvin. Okay? I hope that's clear. Alright. So, let's have this SAQ2. Marami ditong nalito. So, calculate the density of chlorine gas at 25 degrees Celsius and with a pressure of 600,000 Pascal absolute. Okay. The gas constant of chlorine is given here, which is 117 joule kilogram per Kelvin. So, ibig sabihin, yung R na gagamitin natin ay hindi yung sa gas constant ng hindi sa gas constant sa formula. So we're going to use the gas constant of chlorine, which is given dito sa formula ay sa problem. So here's the formula. So the pressure is given. It's already Pascal. You don't have to convert it. Our R is so ang gagawin nyo lang is i-multiply ang value ng density to acceleration due to gravity. Remember ano ito This is constant acceleration due to gravity. This is density times acceleration due to gravity, and the unit is Newton per cubic meter. So when we computed from SAQ2, the density, i-multiply lang ito sa 9.8. Ang tatlong ito, compute the specific volume. Napakadali lang ito. Remember that specific volume is the reciprocal of the density. So ang gagawin nyo lang is 1 divided by the computed density from SAQ2. Okay? So huwag kalilimutan ang mga formulas from the previous topic that we had, because still they are applicable to and related to some topics that we're going to encounter in the future. Okay, so I hope that you will be able to understand now this concept, especially itong calculation. Madali lang naman. As long as that you have a formula, you convert the unit to its right value, so you are good to go. Alright, so later on I'm going to give you more activities about this topic, and for you to be able to gain more understanding about the concepts of air density or atmospheric density. Okay, see you later.